Is the name of the chapter. This is always a tricky chapter. There's so much information like packed inside of it, which is why your notes packet is super intense. Also, it's a little different than a normal notes packet because the copier was broken, and so I had to like print the pages over there and then staple them together, like we were back in the olden days. So that was fun for me. Rational expressions, do you hear the word ratio kind of embedded in rational? So you can even see it, right? Those first couple letters of rational are ratio. Rational expressions are when you have a fraction. That's all it is. So it sounds like it's something more intense. It's not. We're going to start by just simplifying fractions. This is where I use my handy dandy post-it notes when there's a lot going on and it looks overwhelming. So if this, what I do right now, helps you, you can always grab some of my post-it notes. I have a lot of them. You're welcome to them to use to help you. So do you see how I made that problem look a lot easier? Yes, we're going to take it in bite-sized pieces. So, once I find a pencil that has Lego. Hold on, there we go. All right, let's start with just that fraction part right now. If I look at 10 over 25 and I needed to reduce that, what would it reduce to? What divides into both 10 and 25? 5. So if I divide in, what do I get in the top? 2. If I divide in, what do I get in the bottom? 5. Okay. First part, check. Alright, so I dealt with that. Now let's move over a spot. So again, this is why I like this, because then you can cover up the stuff you don't need quite yet. I have x squared over x to the 5th. Do you remember what to do when you have exponents in the top and bottom? Subtract. So if I do 5 take away 2, what do I end up with? 3, and it lives where the bigger exponent was. So it's x3, and it lives in the bottom. And I'll show you another way to think about that in just a minute. Let's finish off the problem first, and then we'll talk about another way to think about the fractions here. Okay, we've got our y's last. 4 take away 3? 1. Where does it live? In the top, because that's where the bigger exponent is. I wrote my 1 in. Do I need to write the 1? No. But is it hurting anybody? No. So you can write it or not. It's up to you. Okay, let me just look at a little chunk of this for a second. Let's look at just the x's for a moment in time. So let's bring this over here where there's some extra space. So do you see how we had x squared over x to the 5th? X squared is really x times x, right? We have 2 x's. X to the 5th, how many x's do I have? 5. 1, 2, 3, 4, 5. What happens when you have the same thing in the top and the bottom? They cancel. So do you see how this cancels and this cancels? How many x's do I have left? 3. And where are they? In the bottom. So if you ever forget what to do, right? So you get to your homework and you're having a moment and you're thinking like, I don't know what to do with the 5 and the 2. Remember, you can always draw it out. Like, what is x squared? It's x times x. What is x to the 5th? It's 5 x's. Cancel stuff out and see what you have left. The other way to think about it is you subtract your exponents and then it lives wherever the bigger exponent was. Okay. So that was the only one like that, unfortunately. Do you see how it gets a little more intense from there? All right. Do you remember when we did the unit on factoring and we had so much fun? Maybe you don't remember it that way. Maybe only I remember it that way. So these, we are going to factor and cancel stuff out. All right, look at the top for a minute. So again, I can use, this post-it note comes so just in handy. All right, so I'm going to cover up the bottom for just a second. I'm going to pretend it doesn't even exist because, you know, there's a lot going on too much. So we're looking at the top. It's not a trinomial. It's not a difference of squares. But do you see how they both have something in common? What are they both divisible by? 2. So I'm going to pull a 2 out front. Do you remember taking stuff out front? We called it common monomial. Does that ring a bell? Maybe? No? Okay. 2 times what would get me back to 2x? 2 times what would get me back to 10? 5. So common monomial is when they have something in common that you can pull out front. It's like reverse distributing. So if I multiplied this back out, 2 times x, 2x. 2 times 5, half. So if you distribute it back through, it should multiply back to where you were. Okay? All right, now I'm going to cover up the top because I already dealt with it, so I don't want to look at it right now. In the bottom, do you remember doing difference of perfect squares? Okay, so that is the form where we get 2 sets of parentheses. One has a plus, one has a minus. And remember, the order doesn't matter. So you could have the minus and then the plus. Okay, so it's forgiving in that way. Because remember, when we multiply, we have this commutative property where the order doesn't matter. So 2 times 3 is 6, but 3 times 2 is also 6. So it doesn't matter if the plus or the minus comes first. Okay, do you remember how I find the stuff that goes inside? Square root. Yes, both parts, right? Okay, so what do we know the square root of x squared is? X. That goes here and here. So you square root the first thing and that goes in the first spot in both. Square root the second thing. What do you get? And that goes in the second spot in both. And sometimes you'll find that when we come back to a topic, even though we're not doing the topic in exactly the same way, sometimes when you come back to the topic, it's like, oh, that makes more sense. Like I needed just to see that one more time. Okay. Do you see how you have some lovely things in the top being multiplied and then some things in the bottom? Remember, if you have the same thing in top and bottom, they can cancel. Do you spy with your little eye something that's the same in the top and the bottom? Yeah, it has to be the whole set of parentheses. So it can't just be like, oh, I see an x and then an x over. Like it has to be the whole thing, okay? So in the top, what do I have left? 2. In the bottom, what do I have left? X minus 5. And then notice if we go back to the initial statement that was up here, is that we are going to assume the denominator cannot be 0. So if I think about this problem, for example, you go back here before you simplify. X couldn't be negative 5 or positive 5. Agree? Because 5 would make this 0, and 0 times this would be 0. Negative 5 would make this 0. So there are values that are going to be off limits because if we try to divide by 0, no good, right? Okay. Let's look at the next one. Is there anything I can do to factor the top? No. It is what it is. Sometimes that happens. Like there's nothing you can do. So again, I always go through in order. My brain does the same order every single time. And your brain doesn't have to do the same order as my brain, but I'm going to tell you what mine processes through. I look at it and I think, do they have anything in common? And I'm like, well, 1, but does pulling out a 1 do anything for me? No. Then I think, is it a difference of squares? No. And then I think, is it a trinomial? No. So that's my order of the 3 things. So I always think common monomial first. So my first thing is I'm thinking common monomial. The second thing I think about is difference of squares. That's obnoxious. Sorry about the squeaking. And then the third thing I think about is a trinomial. Okay, so we already saw common monomial, yeah? We already saw a difference of squares. This one has a trinomial. Do you see how I have a trinomial in the bottom? Okay, so let's remember how to do that. That's where you get 2 sets of parentheses. And this is the one where we have to play a game, sort of. First of all, what times what gets me back to x squared? X times x. So I have to have that. Then, to find the second spot, this is where I play the game. What multiplies to 8, I think I have this backwards. Yeah. Can you switch this? This example is wrong. 2 and 4, yeah, no, this isn't going to work. This should be the 7 and this should be the 8. Sorry, my example is not, fix my example. That example is not going to do anything for you. Okay, so pretend that's the 8 and that's the 7. 7 and 8 are still good numbers, they're just in the wrong spot. Okay, now that our problem is fixed, now let's play the game. What times what multiplies to 7 but adds to 8? 7 and 1, and everything's positive because everything here is positive. Okay. We can only cancel whole sets of parentheses together. So if you want to, you could even put this in a parenthesis even though it doesn't need it. So can I cancel something in the top with something in the bottom? Yes. So gone, gone. So I have x plus 7 left in the bottom. What do we put in the top when everything cancels? A 1. So you have to hold the fraction in place. There was a year where I had a lot of people who wanted to put zeros. I don't know what happened that year in school, but it was like a rogue year of students, and they were always like, a 0. And I was like, no. So when you lose either your numerator or denominator, there's a 1 there. Okay? So there's a 1 left. So you can think of this as even 1 times this. So the 1 is still there. Is that okay? All right, flip the page. We've got a couple more. So if you're wondering where we're going to stop here. So no division. We're going to just simplify and multiply today. So like I said, we're going to break it into pieces, but that doesn't mean the pieces are easy, small, little baby pieces, right? So we've got to make sure we're understanding every day. All right. When you have multiplication, the first step you're going to do is multiply. And then you're going to do what we were just doing. So it's almost like what we were just doing, but with a bonus. So let's start with the top. So again, if there's a lot going on and you're like, that's beyond what I'm capable of, you can cover up part of it if there's too much to look at. You can also put in 1s. So if you have any exponents that are missing, you can help yourself out and remind yourself that there's really a 1 there. Again, not something you have to do, something you can do. When we multiply our coefficients. What do we know 4 times 3 is? 12. And then when we multiply, we add our exponents. So this is going to be x to the 7, y to the 8. So now my numerator is all set. And I'm going to move my stick-it note. Look at how handy the stick-it note is today. Who knew? All right, so now I'm going to cover up the top. Again, too much. 5 times 2, 10. We multiply those coefficients. Let's add our exponents. X to the what? Y to the what? 10. All right, so now this looks like number 1 that we just did. Do you agree? Okay. So if I cover up part of it again to make my life a little bit easier, one thing at a time, right? What do I get if I reduce 12 over 10? 6 over 5. Oops. 6 over 5, right? Because 2 goes into 12 6 times, 2 goes into 10 5 times. So we're good with it reducing to 6/5. Okay, so let's move on to the x's. When I subtract, I'll have x to the what? X to the what? 4. And where does it live, top or bottom? Bottom, because that's where the bigger exponent was. Okay, and then uncover the rest. What do I have left in terms of y? Y to the second, top or bottom? Bottom. So this will be my final answer. Is that okay? Questions on that one? Okay. Let's go to this one. These two I treat a little bit differently. Do you see how if I started multiplying, I'm going to want to pull my hair out, right? If this is going to get into x to the fourth, then like, no thank you. Like that doesn't sound like fun. Here's what we're going to do. We're going to factor, and everybody is just going to become buddies in the numerator. There used to be a cooking show, and he was like, we're going to just put everything in the pot, and everybody's going to become friends in the pot. Like everybody, like he would make soup, and he would say everything's just going to become friends when I put it in the soup. That's how I feel about this. Everything's going to factor and then just become friends in the numerator and denominator. So start with just this one. If I'm going to factor x squared minus 64, what does it factor into? So we've got, first of all, do we agree it's a difference of squares? Okay. So I'm ignoring, and again, you can use Post-it notes if that helps. I'm ignoring this fraction completely right now. I'm also ignoring this. So what signs do I need to put in? Plus, minus. Again, it doesn't matter which one's first, which one's second. Square root of x squared is? Square root of 64 is 8. Okay. Do we feel good that we have factored the numerator of that first thing? Okay. Now, let's factor the numerator of the second thing. Do you agree that one's a trinomial? Yeah. So this one's going to be 2 sets of parentheses, 2. So again, everybody's becoming friends in the numerator. They're all together, because when we multiply, we just kind of put everything together. All right, x times x is x squared. What multiplies to 15 but adds or subtracts to 8? 5 and 3. And they're both positive because everything's positive. Okay, do we feel like we factored the top but also multiplied everything together? Agreed. Okay, so we're done with the top. In the bottom, we're going to do the same thing, one thing at a time. So again, look at your list. I always look common monomial first. Is there something in common? 2. Let's take out a 2. What'll be left once I pull out that 2? X plus 8. Because again, if I distribute, 2x plus 16. Okay, dealt with that first one. What is this one? Yeah, difference of squares. So 2 sets of parentheses, one's a plus, one's a minus. Again, order doesn't matter. What goes in the first spot? What goes in the second spot? 3, because we're square rooting. Okay, now, what can I cancel? The x plus 8's, yep, gone by. Anything else? The x plus 3's. Now, here is the good news. I don't feel like in math I always get to deliver good news. I feel like usually I'm like, and this just got trickier. So here's good news today. You don't have to multiply these out. So when you leave your final answer, you can leave it like this. So you can leave just the x minus 8 and the x plus 5. You don't have to multiply it out. If you really love to multiply, though, I am not going to take that joy away from you, and I think you should multiply. But you don't have to. So that's the good news that I have for you today. Good? Okay. Here we go, next one. Oh my. We've got a guess and check one. All right. Everybody's going to become friends in the numerator and denominator. Here we go. I want to factor this one first because it's easier. Let's factor the second one. What does the second one factor into? X plus 10 and x minus 10. Okay. Let's see. So we know we need 3x and x, right? We've got to have that to get back to 3x squared. And then we've got 8. What do you guys want to try? Do we want to try 4 and 2, or do we want to try 8 and 1? 4 and 2? Okay, where do we want the 4? So we're just trying right now. We're guessing and checking. Do you want the 4 here or here? In the second spot? Okay, so let's go 4, 2. Everything's positive, so no need for a negative. All right, let's check. 3x squared, 2x plus 12x. Oh no. Is that going to work? No, that's not going to work. So you want to switch? Okay, let's try switching. So let's put the 4 here, and let's put the 2 here, and let's see. So this is still 3x squared, this is still 8. So the first and the last two terms are fine. 4x plus 6x, does that get me to 10?
Yeah.
All right. This thing, is there something they have in common? 4, so let's take out a 4. If I take out a 4, what's left? X plus 10. Is there anything I can take out in common here? Is it a difference of squares? Is it a trinomial? So it's just going to live on as 3x plus 4. There's nothing I can do there. All right, now let's hunt through and see if I have any matching parentheses. Do I in the top and bottom? X plus 10s go. What else? 3x plus 4s go. All right, so in the top, I still have an x plus 2 and an x minus 10. And in the bottom, I only have a 4. And that's it. Again, can you multiply it out? Yep. Do you have to? No. Okay. What questions do you have for me? Yeah.
Like, there was nothing in the bottom, would you also put a 1?
You would, yeah, you could put a 1, but you could also just make the fraction go away completely, right? Because does dividing by 1 do anything?
No.
No. So let's say the 4 had somehow canceled out too, or maybe it wasn't even there to begin with. You can just write this as your answer. If you put it over 1, though, I'm not going to mark it wrong. It's not necessary, but it's not wrong either. Okay? Other questions? All right, here we go. So tomorrow we're going to divide only. So today we multiplied tomorrow's division. And I know it seems like division's going to be worse, but what do you remember? Huh? Well, no, but do you remember keep, change, flip? That's all we're going to do. So these are really multiplication. These are really the same as what we did today. We just have to keep, change, flip first. So it seems like tomorrow's going to be way worse. It's not. Okay? So I just want to make sure I said that. All right, page 455, 1 to 12. And I will put my book under the dot cam. And like I said, tomorrow will just be division, but it's going to feel very similar to today because we're going to just be multiplying after we do the keep, change, flip stuff.